Good morning and welcome to our webinar series, Studio Offshore Energy. My name is Bob Meijer. I'm director of TKI Offshore Energy, and we run this webinar program about various important topics for the offshore energy or offshore wind energy industry. And one of these important topics that we are debating already for a long time is about standardization. I must say standardization and industrialization. And some time ago, we already presented earlier discussions about this, also an earlier study about the benefits of larger turbines. And of course, the discussion about standardization has really gone loose. I think it's an important topic, and we have asked DNV to do again a study into the benefits, the potential benefits of standardization and industrialization for transport and installation specifically. So this webinar is about this study. Alireza Bayat from DNV will present the results of the study about standardization in TNI. And also we found Wouter Derks from Oord available to give his view and comments on the results of that study. The webinar will be is being recorded so that you are aware of it. It is possible to raise questions in the chat. We'll try to cover those in the half an hour that we've got, but it may not be possible. So what we also try to do is to come back to you afterwards with some answers to these questions. So do raise your questions or comments in the chat. And then without further ado, I would like to give the floor to Alireza Bayat from DNV. Ali, the floor is yours.
Thank you very much. Good morning, everyone. My name is Alireza Bayat, and I'm based in DNV, Norway. Earlier this year, we did a project for RBO and TKI on the topic of standardization in transport and installation of offshore wind farms. And I'm going to present it in the next 10-15 minutes. Can you see the desktop, Bob? Okay, very good. So I just started from here. First of all, who we are. DNV is a global independent assurance and risk management company, and we have close to 14,000 employees and operate in more than 100 countries. And in the energy business, we are more than 4,000 consultants, and DNV has a long track record, more than 160 years ship and offshore class and advisory from maritime industry and from oil and gas and energy together combined is well positioned to support all the stakeholders in this industry in offshore wind. And here is a very quick overview of what DNV has been doing in offshore wind, long track record, and just to pick up a few numbers, more than 30 years experience in supporting the development of offshore wind projects, and more than 85% of all the offshore wind farms are certified by DNV. So I just leave it there for our company introduction. Let's, as the time is short, get into the project. So what we did earlier this year was, here is a summary of the scope. We did an exploratory work on opportunities for standardization and industrialization in TNI, or transport and installation of offshore wind farms. So we divided this, it's a broad topic, so we divided it into a few tasks. We first mapped the current status of the industry in this aspect. Then we identified some opportunities that can be expected to become real in future. And then we did an installation rate and cost analysis of a 1 gigawatt reference offshore wind farm. And finally, we explored some other benefits of standardization and industrialization in addition to the rate and cost. And we checked some challenges and barriers and explored them in relation to these opportunities. So I'll go into a bit of detail of each of these and come to conclusion at the end. So what is the current state of the industry, offshore wind industry, when it comes to standardization? Figure to the right, these are from Wind Europe. It shows how wind farms in the past decades offshore wind farms has increased in size from very small to commercial scale and close to gigawatt sizes. Turbines also have been going through a very high rate of increase in size. And this blue graph is showing average turbine capacity in megawatts connected. These are operational. And the green one is average turbines ordered. And you see the size is constantly increasing, has been increasing. And today we are at around 15 megawatt is a common industry, let's say, offshore wind turbine rating as per now. And there are still some turbine increasing. Let's say the race is still ongoing, but it's slowed down a bit. So with this, in the past 20 years, today the industry has achieved a certain level of industrialization and standardization regarding typical technical solutions for offshore wind projects, like the methodologies for fabrication, for sourcing, for transport, installation. There are vessels out there. There are commercial scale projects going on. But what we see is that there's a notable issue, and that is vessel capacity is still struggling to keep up with the demands of rapidly increasing turbine sizes. So this, let's say, development and R&D has not really led the industry to standardize. But at the same time, we see the figure to the right, again from Wind Europe, shows that most of the turbines in Europe, for example, which is one of the more mature markets when it comes to offshore wind, are actually from Siemens and Vestas. More than 92% of European installed capacity are from these two. And there are very limited, or a handful of suppliers that account for a large share of the installed foundations. So it's a large industry, but at the end, it's a small world. So what we did in our team was we defined some metrics, and you see the maturity metrics on this gray row here, and some items to assess the industry. And what are these items? These are some activities and tools when it comes to transport and installation in offshore wind farms. So, for example, technology readiness level, TRL, is a very common maturity metric. Then we thought about deployment scale, cost efficiency, supply chain integration, standardization and certification, and innovation and R&D investment. And we assess these for each of these as shown in this slide. And we tried to use a traffic light system to show it at the end. So, for example, when you think of vessel design and selection, which is in the planning and development stage, we see the lowest maturity when it comes to several metrics. For example, the deployment scale. Each vessel is being designed bespoke, and the cost efficiency is not really the topic because of the new features and the race for making the vessels for the newer, larger turbines, for example. So for more information, please go to the report. It's a very long assessment here, but we see that when it comes to component installation, for example, monopile installation and jacket and gravity base, for example, monopiles, there's quite a good industry methodology and good practice out there. There are still room for improvement, of course, but it can be standardized. So there are some items that need more attention. And at the end, digitalisation is also a big topic, which there are room for improvement. Then I go to the next topic, which is about opportunities for standardization and industrialization. So what did we explore? We, after talking to the industry and also engaging internally, DNV marine operations and offshore wind experts, we narrowed down the opportunities into 4 topics. First one, standardized components and procedures. So what does that mean? Standardizing the design of turbine and foundation components, as well as transport and installation procedures. These can streamline operations, reduce variability, and enhance efficiency. This includes standardizing foundations, installation vessels, and logistic processes. And for this, cooperation between turbine manufacturers and component suppliers and transport and installation contractors can be beneficial. The second opportunity is about automation and digitalization. And by leveraging these, we can optimize T&I operations by improving precision and reducing human error. The third topic is modularisation, which is the process of dividing a system or product into smaller self-contained units called modules. And wind turbine can already be viewed as a modular system, as it consists of components such as blade, rotor hub, drivetrain, nacelle, and tower modules. So this can also, individually, we can work on this modular design and improve it, standardize it, such that it gets more efficient when it comes to transport and installation. And opportunity number 4 is supply chain optimization. And what do we mean? In industrializing the supply chain improves coordination among suppliers, manufacturers, and logistics providers. And it will lead to reduced lead time, lower costs, and better project timeline. Then, in the shortness of time, I go to the next topic or task, which we then assessed for a reference wind farm, 1 gigawatt wind farm. We assessed, what if we had these opportunities? What would happen if we had those in a future scenario? So we used 1 turbine size. We thought, okay, let's go for 18 megawatt. Let's say this is a megawatt rating, which the industry has agreed to standardize there. And then we assessed the installation rate and cost of this 1 gigawatt wind farm with 55 turbines on monopile with transition piece foundations, and distance to port of about 70 nautical miles, which is about 130 kilometers. And for turbine installation and foundation installation, we thought, let's use jack-up vessel for this hypothetical scenario. And then we did the analysis of this installation for this wind farm from activities from load out to complete installation of the foundation and turbines. So we divided these steps and we defined the sequences and how long it takes and what is the day rate and tools and things around it for costing it up. So we did this in an Excel model, and then we applied 2 scenarios to it. Case A is when we have standardization of components and component handling. So if these were standardized and we had this in place, what would have happened? And then for each of those steps, we applied efficiency factors one by one, and then came up to the end where we are then, comparing to the original case. And for the case B, we improved the logistics and offshore operations. We there assessed the opportunities related to automation and digitalisation. For example, when it comes to, for example, improving efficiency for transition piece installation using robotic systems for bolting, or when it comes to planning, improving efficiency in engineering, project management activities using digital twins and digital logistic optimization. And for the component, it was like, when you have standardized designs and tools and processes. So there's more efficiency in doing the installations. And then for the monopile, transition piece, and turbines, and the engineering work and project management of that installation package, and also procurement and sea fattening on the vessel, we assess these for their base case, which is the graph on the left, and the bar chart on the left side of this graph. And then case A and case B, how much reduction in both durations, as is shown in the table to the right, and the cost we can achieve. And together with this 12% and 15%, we end up with 25%, which is by multiplying these together, not summing, multiplying these two efficiencies, give us 25% at the end delta in efficiency for doing transport and installation. And this is significant reduction. This is just about having the turbine rating where we are and working on transport and installation standardization. And this can really benefit the industry, which I'll come back to it at the end of the presentation. So there were two other tasks. First was, I just go quickly to these. Other benefits of standardization and industrialization, except from faster processes and lower cost, we can have enhanced safety, increased labor productivity, improved quality and reliability, environmental benefits, and scalability and flexibility. And I suggest, I encourage you to read the report in detail about each of these benefits. And what are the barriers, knowledge gaps, and innovation opportunities here to achieve those, to achieve the standardization in transport and installation? Technical capability and compatibility. There is a problem there between the components and the installation vessels and contractors also. Investment and upfront costs is a big issue because it needs a lot of resources and investment to think of the next installation vessel, among other things. Workforce adaptation is a problem. Innovation opportunities are there, and then rules and regulations also need to be adapted for the standardized processes on transport and installation. So I just go forward. Yeah, you can read more in the report. And this is my final slide. The conclusions from this study was that we can achieve significant reduction in cost and installation rate by standardizing the offshore wind industry, especially when it comes to the transport and installation. Then we will have a more limited range of component sizes and masses for turbine components, foundations, and installation tools. And this approach will enable the supply chain to prepare for the anticipated high demand. And we need to align all stakeholders, the developers, original equipment manufacturers, and contractors on a unified approach for this. Standardized solution reduce complexity, enable training, and optimize vessel use which leads to faster and more cost-efficient project execution. So we need the entire industry to collaborate for this, and we need transparent communication for this, which is a bit of an issue in a competitive market. But at the end of this, we will show you an example which DNV is running. And as the introduction of larger and more efficient wind turbines slows, because the rate has slowed down a bit, the rate of turbine increase, it's expected that the growth of wind turbines will also decelerate, and this will create opportunities for a standardization and industrialization. So there's an opportunity now to adopt the supply chain-wide perspective for standardization, including the transport and installation. So with this, I summarize again our identified opportunities: standardization in design, equipment and procedures, automation and digitalization, modularisation, and supply chain optimization. Thank you very much for your attention.
Well, thank you very much, Alireza, for a very clear and concise presentation about this extensive report. And you already encouraged the audience to read the report, and I can do that again. We'll put a link to the report in the chat so you can find it easily. And it contains, of course, all the underpinning data that was just presented. Very interesting. It's a great perspective also on the future of offshore wind, but there are important steps to be taken to make this happen and to materialize these benefits. And yeah, to have the entire industry collaborating on this is, I think, a great outlook and also complicated. So I already announced that we have Wouter Derks from Van Oord in the audience. And Wouter, I would like to invite you to share your views and comments maybe about what was just presented about this topic.
Sure. Thank you, Bob, for introducing me. Thank you, Alireza, for presenting the report. I didn't prepare a nice slide on what Van Oord is doing, but for you who do not know, Van Oord is a contractor in offshore wind already since 2005. I think some 20 years ago we started and have been involved in the installation. I don't have the figure exactly in mind, but I think it's something between 15 and 20 gigawatts installed offshore wind power, in which we have been involved in. That varies from EPCI contracts like the Gemini project in the Netherlands to installing wind turbines in the United States or laying cables in Taiwan. So a 20-year timeline of projects across the world, although the majority, of course, in Northwestern Europe. I've been working in Van Oord for a long time, and since 2012 in our offshore wind position. It was an honor to have the report early and being asked to have a look at it. I hope that my experience in the industry helps to give a good perspective from industry side on what has been presented. So let me first reflect on what came to my mind when I was reading the report. And I would like to close off with two questions for Alireza. But first, the perspective. When I read the report, there was a lot of recognition on my side. Also, the reported feedback from other industry partners like DOF, Jan de Nul, and Fred Olsen. That response was expected. I think the industry sees the same thing in the challenges and the opportunities, the things that make it difficult to improve, to standardize, etc. I think for me it's difficult to comment in detail on the results of the presented economic analysis, but it would not surprise me if the figures that you're presenting are in the right ballpark. That having said, I'm not so certain whether savings in T&I will always result in a lower LCOE. Of course, making things more efficient always helps, but if it comes to making things cheaper in TNI by standardizing or modularisation, whether that helps to make to reuse the L3, I do not have an opinion there, to be honest. An example, for example, of where my doubt comes from is that if you have to realize offshore wind capacity in very difficult locations, you require a bespoke TNI solution. There's not a standard solution for a installation of wind capacity in deep waters, very severe mid-ocean conditions, bad soil conditions, what have you. So the turbine may be standard, the site and the local conditions are never standard. If the turbine would be standard, the soil and the mid-ocean conditions will be driving the design of the foundation, and to a large extent then also the TNI costs. Another aspect related to logistics is that the location of the site relative to available ports, or it is in a certain country, may constrain the use of certain transport methods. So local legislation may require or restrict the use of certain equipment, and also sometimes even prohibits to make use of certain suppliers. So that also is complicating industrialization, standardization in TNI. I want to share some observations on the investments that relate to TNI. You said something about that, Alireza. What we see happening at the moment is that there is a significant growth of installation capacity for turbines in the range of 50 to 80 megawatt size. And some are even capable of going bigger, but that seems to point that there is sort of trust in the market of investors that we are reaching a sort of cap maybe in this turbine size. And people are not waiting to invest in vessels for that capacity. That fleet is growing. And they all follow the similar design. Most of them are jackups. It's apparently really focused on bottom fixed foundations. So jackups with sufficient deck space and sufficient crane reach. At the same time, we see lagging investments in the installation capacity of the foundations for these turbines. And we also see lagging investments in ports. So apparently it is quite difficult to make decisions given the uncertainties in the number, the speed, the location of the project developments, and also on the foundation dimensions. And I'm not so sure whether and how standardization and industrialization can improve the investment appetite. I tried to find an example, but I could not really find a good example of how we can resolve that challenge by looking at standardization, industrialization. So what's my view on what we can gain by standardization? My personal gut feeling is that we are still in a stage that in TNI we can mostly gain by innovating than by standardizing. You mentioned in your report a couple of good examples of innovation, which I fully agree. So robotization, the use of innovative sensors. I think augmented reality can be helpful. Making much better use of data, that can also help. It will make our work safer and faster. But these industrialization technologies are, in my opinion, often proprietary and not so much the result of standardization or agreements in the sector. That is really coming from a technical sort of strategy that companies have to be able to be more competitive.
Yeah.
Yeah.
Well, Wouter, I think it's really great to have your perspective on this. It doesn't all look like smooth sailing just to implement this. And there are these intricacies of the local conditions that also limit the use of equipment. It is not as easy as it seems. Still, I think there is a great opportunity to further dive into this. And I think if I'm looking at the clock, so we've passed the half hour, so we are going to wrap up now. And I know that you still have some questions, and that's great, because we're going to take your questions and discuss them with Alireza and feed them back to the audience. That is still going to happen. I've put the link to the report in the chat. I also wanted to mention that DNV is also working on a joint industry project that we can't discuss right now, but it is about this very topic. So the industry is really working hard on making the benefits of standardization or more industrialization materialize. It's also very much part of our innovation program of TKI Offshore Energy. And I would advise you to keep an eye on our newsletter, subscribe to this. You can find it on our website and our social media, because we will be talking about also future subsidy tenders that can also apply to this very topic of standardization. So with that, I would like to thank very much Alireza Bayat and Wouter Derks for their contributions in this webinar. And of course yourself, the audience, for attending this at this early hour. And we will be coming back to you with more webinars in this series. Thank you very much and have a great day.